Hello and welcome to Citizen Report, a dynamic, cloud-based web application designed to allow citizens, like you and me, to easily and securely report public infrastructure problems. My name is Jack Ford, and I'm the lead backend developer for our application. What you see here is the main login screen, where users are directed to after creating their account. Here, users can access the application through our login with built-in SQL injection protection using their credentials. Let's log in and see how the app works.
Thanks, Jack. We chose to make our app web-based so that anyone can easily access it, from Android and Apple phones to laptops and computers. We created the front end using HTML, CSS, and TypeScript. Going into this project, I'd never used TypeScript before, and I learned a lot about the language going through it. Because the goal of this app is to empower any citizen to report infrastructure problems, we thought that the most important aspect of designing this app was that it was as simple to use as possible. So we went with a very clean design style, which will allow anyone to use it. We also decided to use the Google Maps API, as many people are very familiar with this interface, and it easily allows for pinpoint accuracy when locating specific locations on the map. All you have to do to report an issue is choose the type of issue you would like to report. Currently, we have 4 classifications: pothole, debris in road, uneven road, and traffic light issues. We opted to begin with these as our prototype, but it would be fairly straightforward to add more if we wanted to. After selecting your classification of issue, I will choose a traffic light. You simply need to choose the location on the map where you would like to report an issue. Then, you'll be prompted to enter an optional, but highly suggested, further description about the specific problem. So, in this case, close this, and your description is recorded there, along with your type of issue and your recorded location. All this data, as well as the user that reported the PIN, is stored in our database and will be reloaded upon opening the application. Using the information from the database, we could send a report of issues to local authorities to ensure that all infrastructure problems affecting residents are known. Thanks, and back to you, Jack.
Thanks, Nolan. I will now briefly explain the backend technologies used to deliver a secure and seamless experience to all users. The core backend server was programmed in Python using Flask, an open-source microweb framework trusted by thousands of companies around the world, including Netflix. This server interfaces with a database to supply the website with necessary functionality, such as adding and storing pins at their specific locations, accessing specific pin data, and managing all account information. The server is hosted by Amazon Web Services, a cloud hosting solution with more than 1 million active users. We chose AWS to host our server as it is highly secure, scalable, and affordable. Due to the importance of user data security, we also employed industry-standard privacy protection to store user credentials and other private information. Before being stored in our databases, passwords are both salted and hashed using the bcrypt algorithm. These elements combine to create a fast, reliable, and highly secure website for all users to interact with.